Hi everyone, welcome to this session. So first of all, thank you for joining this session. I'm going to talk about the art of event-driven observability with OpenTelemetry. So in the title, you have a lot of things and you can hear OpenTelemetry. So of course, I'm going to cover OpenTelemetry. So without any waiting anymore, let's start this presentation and jump into the content. So before we start, I will briefly introduce myself. So my name is Henrik. I am a cloud native advocate at Dynatrace. And prior to Dynatrace, I've been spending most of my career as a performance engineer. So breaking things, tuning things, optimizing things. And because performance engineering is still in my heart, I try when I have the time, depending on, of course, the task that we have in our mission. I try to produce content for a podcast that has transitioned to a YouTube channel called Perf And otherwise, 3 years ago, I started the adventure of building a fresh new YouTube channel called Is It Observable? So it's out there, check it out. And to improve the content, of course, I need your feedback. So what I'm going to talk about in the next 25 minutes? Well, a couple of things. Because I don't know how much you know about the OpenTelemetry project, I will need to introduce a couple of components involved. And in this session, we're going to mainly focus on traces because OpenTelemetry covers other aspects, but here, this session is all about tracing. So we're going to see how we can produce tracing with OpenTelemetry. And because it's going to be about event-driven architecture, we're going to cover the various way of instrumenting your application using OpenTelemetry in an event-driven architecture world. And you will see that there are a couple of components and especially span links, and we're going to cover that through this session. So let's start. And before we start, I would like to share a story, in fact. So when I was a kid, my grandma and my mother, they loved to draw. They would like to paint, and I was pretty bad at that. So they teach me how to start drawing things, the methods around that. And it was quite funny because the first assignment that I had as a job was basically in an IT environment. I had a manager. We were dealing with different applications, different components involved. And he said, "Hey, could you draw me the actual state of our environment?" And I thought, oh, that's funny. It reminds me of what we did with my mother and my grandma a couple of years ago. So I looked at the tools that we had in mind, in place, and we have mainly tools that you may know, like Nmon, Top, pretty really deep dive solutions that give you pretty good understanding of what's going on at that moment, so you get points. So with this type of tools, I was able to get like this type of drawing, this type of representation of the web server. You would say that, it's just points, very difficult to imagine what's behind the scene. Yes, it's true, but imagine it's like a pixel. You zoomed in very on a very low level to the server, but you don't understand the right context. So that was actually what I was able to do with the tooling that I had at that time. Then 20 years ago, solutions were improved. We have more solutions around it. And we have this SMDB approach where we're attaching metadata and we will storing the data points that we were collecting. So at the end, instead of having just points now, I was able to draw lines around it. So now we have a better shape. Again, it's very difficult to understand what's behind that web server again, but at least with the tools, I was able to improve the visualizations. Then 13 years ago, there was a lot of new product coming in the market. So application performance monitoring solutions, so APM, where they're providing various features like dispute tracing, like end user monitoring, synthetic monitoring. So at the end, you have much more better understanding what's really happening in your environment. So with this, this web server now has eyes, has nose, has a mouse. So at the end, the shape is a bit more representative, but still we are far from what I had in mind to represent, in fact. Then 10 years ago, because we were generating so much logs in our environment, so first we had to collect that. That's one task. And then we have to index those logs to get some extra details. So with, logs is very verbose. There is a lot of details, and it's sometimes we have too much information. But with that information, I was able to improve again the visualizations. But here you can see that I was only able to get the left and the right arms of the web server, which was better. But again, I was very far from what I was really wanted to represent. What I actually wanted to represent was this child here, sitting in a park or in a forest. So there is a surrounding, there is some nature around the character. And you can see that the child has clothes. So there are a lot of details that I was not able to represent at that moment. Why was not able to represent those tools, the situation? Because I was missing some tools. And in fact, what are the artistic tools that we have available to be able to draw a real clear picture of what's going on in our environment? Well, I have no secrets for this. This is observability. We need, of course, different type of signals. So logs, we mentioned a few minutes ago, events now with modern systems like Kubernetes, or even we build solutions, we have events, and those events add even more context to our data. So it's very rich to get those events back in our solution. Metrics, of course, we talked about it in the beginning. Traces, very popular and was out there since many years. But now with OpenTelemetry, it's even more popular. And traces is great, but usually you want to shift to another signal, which is profiling. So profiling is obviously much more important because you will have more details about what's going on. So it's great to have those signals, but again, without metadata, without context, those signals won't help you so much. So what type of information we need to attach to those signals? We need to have the technology involved. We need to have which server, which service, which deployments, which version we're referring to, which geo, because most of us are deploying on the cloud. So if we don't know that we are referring to a workload deployed in Europe or in US, it's going to be even harder for us to understand. And what is a clear situation of the market is that over the years there is specific toolings for storing those data. So you have specific solutions to store the logs. So Elasticsearch, Loki, there's plenty of them out there. So logs has been very specialized. We use those tools for this. And then we have traces. So there are specific tools for traces. Profiling, there is also specific tools for profiling. And at the end, what we intend to do is to try to separate those signals in different storage. And this is not helpful because at the end, when we need that data, usually it's fire over or in our environment. So we need to drill down and debug and understand what's going on. So that's why separating the signals is maybe a solution, but it's not going to be help us to be efficient when we need those data. So we should stop doing this, and we should bring every signals into the same storage. So then we are more efficient to deal with our problems. So I mentioned those artistic tools, but again, it's going to be very complicated to use them. And that's why a project like OpenTelemetry is just fabulous, because now we'll see that we have different tools out there, the pencils, the pastels, the brushes, different type of size of brushes that will help us to shape the visualization that we need for our environment. So what is OpenTelemetry? OpenTelemetry is an open standard that basically help us to build telemetry data, so logs, traces, metrics, and from our environment in a standard way, which means I can have my code, which is completely agnostic, producing telemetry data, and then I will send that to any of the storage backend solution of the market, like Dynatrace, for example, or others. I have the options now to shift to decide where I want to move those data. And if we want to summarize the project, there is obviously two major components involved. There is, in one hand, the instrument. So basically, in our code, we will produce metrics, traces. So we will produce sounds of our code. And then there's the other component, which is optional, but at the end, we usually use it quite heavily. It's called the collector. So it's a bit like an amplifier. So produce sound, we send it to the amplifier. And then with the amplifier, we have the options to put effects. I want to add some chorus, some overdrive. So I can change the sound, and this is the collector can do that. You can change the telemetry data on the fly and then decide where we're going to send it, either to the amplifier itself, or we're going to send to another amplifier to do even broader signals to other backends. So at the end, if you look at the project itself, OpenTelemetry supports various signals. So metrics, traces has been out there and very stable, so you can rely on it without any problems. We have metrics that is also stable, so no problem of using it. Logs, we should see it probably next couple of months, but again, it's still in alpha release, I would say. So be patient, but it would be there out there. It's exciting to get at least a standardized format for the logs, because logs is a bit like a Wild West. Everyone is producing the logs in their own format. And last, continuous profiling. But again, this is the specification is still under constructions. For traces, it's very simple. You will need, for example, to add the OpenTelemetry SDK in your code. So you will be able to manually produce traces from your code. So you would say that tracing manually sounds very expensive for an existing application. It means that I need to change all my entire code. So I'm not going to go in that direction. Don't worry. That's why there is the other option, which is automatic or semi-automatic instrumentation, where you add an agent or semi-agents, depending on technology, and this agent will auto-instrument well-known framework of the market. So if you use a very popular framework of the market, those will be instrumented and you get details out of that. But if you're doing manual or automatic instrumentation, there are core components that will be common. So first, a trace. A trace is technically a technical transaction going on the system. So a trace at the end is made of span. Each span is a sub-step in your technical transactions. And to make this trace, technically, if you could look at the trace, it's a big JSON array and every element of the array is a span. So how does OpenTelemetry attach those spans together? Well, with the help of a trace context. So trace context says, this is my trace ID, so I'm part of a trace, and this is a span ID. So then I have a reference of my step, who has called me, so the parent, and then with all those details, when this event has happened, when it has ended, then we're able to produce that distributed trace that we will see in a few minutes. So basically see the entire transactions. So to be able to do that, we need a couple of things. We need to create the context, and we need to have the service information. So we'll see that there is a standard way of doing this, the service name, the semantic conventions, depending on technology, will add extra details, and those details are important. I mentioned you need context, and this will be done automatically with the help of OpenTelemetry. So what is the journey to instrument your code? So first you have your app, no surprise. You add the OpenTelemetry API and SDK in your code. Okay, and then there are common objects that you will have in any language of the market. You have two objects that is required to create spans. The first is a trace provider that will define the span processor. So I'm not going to detail on this, but it determines how the spans will be sent, how often the spans will be sent to the backend. We have the sampler. We'll talk about it in a few minutes. We have the exporter. Exporter will determine where we're going to send those data, to a collector or directly to your observability solution of your choice. And we have the resource. Resource is the identity, the passport of your service. I'm service A, version 1.0, whatever it is. And then we have propagator. And we'll talk about the propagation in a few seconds as well. And then once those two main objects has been defined, then I'm able to create the various spans into my code. So let's talk about the sampling. So the sampling, you'll see when you deal with OpenTelemetry, you obviously will produce a lot of signals. So there is different sample decision available in OpenTelemetry to determine how much data you want to transition in the network and store in your backend. So the first one is always on, which means that 100% of the data that has been produced on the code will be sent to the backend. So 100%, lots of details, but it may sound very expensive. But again, you have to figure out the right balance. The second one is always off, so nothing, 0%, so the opposite. The other one is parent-based. So parent-based makes sense when you have a dependency. For example, here in this example, we have service A, and then we have service B. So the service B is a dependency of service A, so I will define it as a parent-based, which means service B will only send the spans when it's involved in two transactions. So to avoid having the noise of the health checks, the readiness checks that may happen in the background of your service. Then you have a trace ID ratio. So you define, okay, I want to have 20% here, 30% here, 10% here. So you define a percentage of how much data you want to send back to your observability solution. And last, there's a combination of parent-based and always on, parent-based trace ID ratio, and parent-based always off. So let's take an example. So service A will be trace ID ratio with 50%. Service B will be parent-based a trace ID ratio with 25%, and the other dependency will be also configured as parent-based a trace ID ratio. And if we take that example, 50%, 25%, and so on, then it's really important how you configure it, because as an example, let's say we have 1,000 requests coming in the system. And if we're looking for an end-to-end trace from A to E, at the end, with these settings that I've defined here, I will have only one request that will have an end-to-end trace. So at the end, you can see that the sample decision that you are defining could be quite sensitive on the details of the level of detail that you need for your environment. Then I mentioned propagation. So what is propagation? Propagation is a way of attaching the spans together into a single trace. So if I have the first service A, very simple, I initialize the trace. So the context has been defined. So then every single methods and functions called in the service A will be attached to the same trace, no problem, because the context is there. But how can I make sure that the trace will continue when I'm calling the service B? Well, this is where propagation comes in the picture. In the case of HTTP, very simple, we will inject a header in the call to service B with the trace context, so trace ID and span ID, which means then the first thing that service B is doing is extracting the trace context, and then from there, it can continue the trace, and then I will have an end-to-end trace from A to B. So why I'm saying this, because in the normal HTTP world, it's quite straightforward, but you will see that in the event-driven architecture world, the trace context is not so much standardized. It means every single broker or Kafka or technology, I would say. So Kafka, you said it in the headers. If you look at MQTT or IMQP, it's going to be one of the property of the message. So you have to figure out how the broker works and how you pass properly the trace context within the technology. So in traditional microservice architecture, tracing is awesome because at the end, with this, I'm able to keep track on each individual calls that happens in my environment. So at the end, it provides me a great visualizations that, for example, here's an example where I have a trace from a microservices architecture. And here, if I want to optimize, for example, that transaction, I can say that here I'm spending 25 milliseconds, and I see that I'm spending most of my time on the list recommendation. So that means that if I want to reduce the time, I will simply need to reduce the list recommendation methods, and voila, I have optimized the methods. Again, in the other trace, I can see also that get product has been called 4 or 5 times. So then I can maybe think another way to reduce the number of calls and to optimize service. So at the end, the tracing brings lots of details for me. So you say, okay, great. Okay, you're talking about microservices, but the title of the talk is about event-driven architecture. Okay, sorry. Let me bring the event-driven architecture piece here, because here the difference is that we can start in the event-driven architecture world. We can start with a simple HTTP methods going from one services to the other, and then suddenly we send a message to a broker, and the broker will basically interact with, can have several consumers. So I publish a message, and then I can create several consumers that will take that message and do something, to process some batch or to process some data, to store some assets somewhere else. And at the end, when you do distributed tracing in the event-driven architecture world, you have 2 options. Either you do a big end-to-end trace, or I can do separate the traces. So let's see the first example. So let the end-to-end trace. So for this talk, I have prepared an environment. So here is the GitHub URL, and I have different components. I have the OpenTelemetry demo, just to make some noise. And then I have the event EDA, which is a namespace with one consumer, one publisher, so publishing messages, and then 2 consumers that will consume the message. And so we will see the various way of tracing that system. So, it's demo time, all right? So now, let's bring the, first I want to show you the code aspect. So if you look at here, I'm just bringing up the EDE in the screen. Okay, here it is. And first thing in this repo, you have the consumer, 2 consumers, you can see, and now we have publisher. So if you look at the code of the publisher, the first thing that I did here, of course, I'm adding the OpenTelemetry SDK to be able to instrument. I am creating, like I mentioned, a trace provider here with an exporter, batch span processor, exactly what I described a few minutes ago. And then when I produce the traces, here in my case, I'm using a specific broker provided by Solace. So what I'm doing is I'm getting the trace context from the actual HTTP call, span, trace ID, and span ID. And then with the help of the methods provided by this technology, I am injecting the trace ID and span ID to the message. Very important, because at the end, I want to make sure that the trace will continue with the consumers. So then if you take one of the consumers, so this one, for example, here, same thing. I still have the OpenTelemetry API in SDK, so no surprises. But you can see that in the consumer, once it's received the message, the first thing it's doing, it's extracting the trace ID and the span ID. And with this, I'm able to create a new trace context. And then from there, I can create a new child, and then it will continue the trace with that. So what do you get out of that when you have deployed this application in your environment? Well, let's open the browser. So first of all, when you come here, this is Dynatrace. I'm storing the data into Dynatrace. So first I will have diverse services reference. So I have the consumers, the publisher, and so on. And then I can also look at the topology with different interaction with different services if I want it. So you can see publisher and consumer, I have the interactions. But then what I would like to show you is what we get with the actual end-to-end trace. So here is the actual end-to-end trace. You can see that we have a publisher with a couple of steps, and then we have the trace continue with the consumer database with a couple of steps, and then we have the other consumer that's continue. So that's great. We have all the details. But let's have a look at the actual trace. So you can see here we have a 2-minute trace, which is quite long. So I have the details of each consumer. That's great. But then at the end, the publisher itself, it's few milliseconds. I barely see things. So for me, dealing with that trace will be very difficult and very hard to optimize things in the future. So that's why we saw a few minutes ago. So we can see that it's not the ideal representation for us in this particular applications. So I may try to change it. So that's why we have the other options called the span links. So what is a span link? Well, you saw that a few minutes ago. We have a publisher taking 200 milliseconds, and then we have two consumers that takes 1 minute or 2 minutes each for each task they have to do. And it's quite long. So at the end, the representation is not helping me to be efficient when I need to troubleshoot. So now what we want to do is to change that end-to-end trace using span links. So at the end, the publisher will produce the trace, and the consumer will use a link saying, oh, I'm part of an existing trace, and I'm making a reference to the publisher. So then you can still jump back to the publisher from the consumer. So let's see now that's other representation. So what is the difference in terms of code? Very simple. So here I have the publisher will be the same. So I still need to add the trace context into the message. Otherwise, I won't be able to create the link. But let's look at the other version from the consumer perspective. So we'll have of course, similar to previously, the OpenTelemetry API in SDK, no surprises. And then I will still need to extract the trace context because I need to create that link. So here I'm creating the span context. With the help of the trace ID and the span ID. And then here you can see that what I'm doing here, I'm creating links. You can create several links, by the way, on a trace. But here in my case, I only have one link. So I'm creating a link with only one asset. And you can see that when I'm creating the new span here, I'm saying I'm creating a new span. And by the way, it's going to be linked to another trace available somewhere else. So what does it mean in terms of representation in the UI? Well, let's have a look at it right away. So now I have another example here where I already have created from consumers this usage of span links. So you can see that I have the details of each steps. And if you look at the top of the trace, I can see that I have a link here. So which means if I click here on the link, I will be able to go back to the publisher. So then I'm able to have the connection between the publisher and the consumer to the publisher. Same thing with the other services, the consumer database, same thing. All the steps is described, detailed. And here I have the link so I can go back to the publisher. So at the end, in this particular application, the span links for me was more useful. But again, there is no standard. You will have to decide which representation fits best for you. That's why it's an art. Observability is not a standard approach. You have to figure out the best way of representing your systems. So the pros and cons of using span links. So first, you keep track from the consumers to the publisher. That's interesting. Then the second aspect, it's improved the visualization, especially if you have long tasks on the consumer side. The disadvantage, I would say, is that you're losing the relationship between the publisher to the consumer. So I don't know one message that I produced, how many consumer has been triggered. So it is a major disadvantage from my perspective. And the other options, that's why I introduced sampling. If my publisher have been sampled, which means the data has been basically dropped, then I have a link to something that doesn't exist. Or the other way, I can have a publisher, but the consumer has been sampled. So then, you have, when you need it, sometimes the data won't be there. So there is some pros and cons. You have to consider about that. Once you understand them properly, then you can design the right observability using the right tools that I mentioned. So the traces and configuring properly the sampling decisions. As a takeaway, for this presentation, I would say first, instrument your code. Now with OpenTelemetry, it's fantastic. You can basically remove agents or vendor libraries into your code. So you can basically make sure that your code is agnostic, which means if you're changing vendor in the future, you don't have to touch the code anymore. You just have to change the endpoint where you're going to send your traces. So much more easier. And this is true for metrics, and this is going to be true for logs, and it's going to be true also for profiling. On the observability data aspects, I mentioned producing metrics, traces, logs is great, but make sure you have enough data, context. So which technology, which service name, which version, add span attributes. So I didn't touch base that, but span attributes, you can add extra information, you can add business information and start not only uploading technical information, but also business information because it's also there in your spans. And be creative. To be able to paint an amazing art, you need to understand your character. You need to understand the environment. So understand your system is key to be able to design the right observability for your organizations. Again, I mentioned about sampling. Keep in mind that there's a project called OPAMP that will probably resolve this challenge of configuring properly the sampling decisions. As of now, you are the one that will configure that, but keep in mind in the future, it would change properly. So, small teaser to the YouTube channel. So, is it observable? This content comes from videos. So, if you want to learn more about event-driven architecture tracing, there's a dedicated episode to that. There's plenty of episodes about OpenTelemetry. Check it out. And again, I need your feedback to improve the content and to be more attractive. So, if you just watch some content, send me your feedback. It will be very useful for me. So, I would say thank you for listening to that talk. And if you want to reach out to me, here are my contact details. You can join me on Twitter. I'm available on LinkedIn. And Is It Observable has the YouTube channel, but also the website. So if you want to look at the blogs, it's out there on isitobservable.io.